Please subscribe to my channel. Thank you for viewing.
This is Eureka Online, where we teach you your subjects and your courses, the topics that are there, such as most especially your science courses, such as mathematics, physics, chemistry, biology, statistics, computer science, and some engineering courses. Okay, I'm going to be taking you mathematics this time, and it's going to be, the topic is on indices and logarithm. Indices and logarithm. Okay, we'll take indices first. What is indices? Indices is talking about an expression that have a base and a power. An expression that have a base and a power. Indices can also be called exponents. Can also be called exponents. Okay? So, expression that have a base and power, such as if you have an x raised to the power a, if you have x raised to the power a, we have the base, and this is power. The base and the power. Sometimes we can have a coefficient. We can have a coefficient. Okay, so A is the base, A is the power, X is the base, and B is the coefficient sometimes. So if there is no B there, that means the coefficient is 1. The coefficient is 1. Okay? It's an expression because there's no equalization sign on it. So in indices, there are laws. There are laws. So we'll quickly run through the laws now. The first law of indices states that when you are multiplying, you add the power. When multiplying 2 or 3 base, when multiplying 2 or 3 more base, 2 or more base, you do what? You add the power. Provided the base are the same, provided the base are equal. If the base are not equal, you don't need to add the power. If the power are even different, you must add it. You can add it. If they are different or the same, but the base must not be what? Different. For example, if you have a x raised to the power 4 times x raised to the power 6. Okay, according to law of indices, we just pick one of the base, which is x, this x. Okay, let me just do this 6 times. So pick one of the base, and we'll say 4 plus 6, because multiplication that's in between them. This will give us x raised to the power 10. 4 plus 6 is 10. Okay, that is law of indices. If we can have it in this way, x raised to the power a times x raised to the power b. Okay, that means we have an x raised to the power a plus b. We can join both of them together because they are what? Different. This is the a, this is b. They are different, so we can't join them together. By introduction of this addition, it has shown that we have performed the law of what? Indices. Law of indices. Okay. Apart from this first law, we have another law, which is the second law. The second law states that when dividing, we call it division law. When dividing, you subtract the power. When dividing, you subtract the power, provided the base are equal. Provided the base are equal. Now the x raised to a divided by x raised to b. It's going to give us x raised to a minus b. Don't forget that the preference will be given to the first one. If a comes first, a must be first here. So if b comes first, b must be first here. But the first one we consider, which is the multiplication rule. We don't anyone can be added, can come first when you want to add. Okay, because Additions are commutative. Additions are commutative. But subtraction are not commutative. Yes, subtraction are not commutative. What do we mean by commutativity? When we change and give us the same thing. That is, when we change the position and give us the same thing. That's what we mean by commutativity. Okay? So take notes of that. Take note of that. Let me give some example. We have 3 raised power 6 divided by 3 raised power 7. This is going to give us 3 raised power 6 minus 7, which equals what? 3 raised power minus 1. Okay? When we get to this rule, I will explain further that we may not be able to leave it this way. Okay? So that is the second law. Third law states that anything raised to the power of 1 is that thing. Anything raised to the power of 1 is that thing. If you have a 5 raised by 1, it's going to give us 5. If you have a 6 raised by 1, it's going to give us 6. So anything raised by 1 is that thing. A raised by 1 equals to A. Okay? P raised by 1 equals to P. So that's the third law. The fourth law. Okay, let me give example. Apart from this, we can have it in this way. That's when we have x raised to the power 6 divided by x raised to the power 3 times okay, x raised to the power x raised to the power times x raised to the power 3. X raised to the power 3. Okay? So, according to BODMAS, you know I want to divide first. Yes, BODMAS, we divide first. So, x raised to the power 6 minus 3. Okay? Then this one, multiplication will add the power plus 3. So, that means we have x raised to the power 3 plus 3. Okay, this will not give us. Okay? So, this is x raised to the power 6. This one did not give us what I wanted. Okay, let me give another one. Did not give what I wanted. So, let's assume we have an x raised to the power 4. X raised to the power 4 divided by x raised to the power 4. Okay, let me use it this way. That will give us, we have x raised to the power 3. Okay, let me use this way. So, which will give us x raised to the power 4 minus 3, which is equal to x raised to the power 1. Because 4 minus 3 equals to 1. So, because it's raised to the power 1 and x raised to the power 1 is that, we say this is s. That's our answer. Okay, the fourth law, anything raised to the power 0 is 1. Anything raised to the power 0 is 1. Anything raised to the power 1 is that thing. Okay? And anything raised to the power 0 is 1. So if I have a raised to the power 0 equals to 1, p raised to the power 0 equals to 1, just put 1 when you start the raised to the power 0. If you say man, raised to the power 0 equals to 1. 3 raised to the power 0 equals to 1. 6 raised to the power 0 equals to 1. 1000 raised to the power 0 equals to 1. Okay, that is how we can do that. You can see that in this example. You can see it in this example. P raised to the power 6 divided by p raised to the power 3 divided by p raised to the power 3. So that means we have p raised to the power 6 minus 3 minus 3. So So which give us 3 raised to power 6. Minus 3 minus 3 is going to give us minus 6, which is equals to p raised to power 0. And 90 raised to power 0 equals to 1. Okay? That is the rule. That is the rule. Another rule is, that is 5, rule 5. Anything raised to the power minus, anything raised to the power minus, result to the reciprocal of that thing. Reciprocal means 1 over. Reciprocal means 1 over. Reciprocal of that thing and its power. Reciprocal of that thing and its power. Look at a raised to power minus 1. A raised to power minus 1 is going to give us 1 over a raised to power 1. So this is a, which is that thing. This is the power of a, which means that this minus will now turn to 1 over. So by the time raised to power 1 is that thing, that's why we are going to have 1 over a. 1 over a. Okay? So what of a raised to power minus 2? We are going to have 1 over a raised to power 2. So the a and the 2. So this minus will disappear and become 1 over. Okay? This one is a raised to power minus 3, which gives us 1 over a raised to power 3. So anything raised to power minus will give us the reciprocal of that thing and the power. Another thing is another law. Another law, I think that this is 5, the one of 6. The one of law 6 or rule 6. Anything raised to power fraction, anything raised to power fraction result into the denominator of that fraction becoming the root of that thing and the numerator becoming the power of that thing. The denominator will become turned to root, while the what? The numerator becomes the power. Look at what we need here. Now so we have a raised to power 5 over 2. A raised to power 5 over 2. It's going to become a. This 2 becomes square root, while we have 5 as the power. Okay? So if you didn't see anything here, that means 2 is there. That is how to handle that. A raised to power 4 over 3 is going to give us cubic roots of a raised to power 4. A raised to power 4. And then we have a raised to power 6 over 5. It's going to give us 20 root of a raised to power 6. So that is how to handle that. That is how to handle that. We can also have it when it's negative. Anything raised to power negative fraction. Anything raised to power negative fraction will result into the reciprocal of that thing, whereby the denominator become root and the power become the numerator become power. For example, you have a raised to power minus 3 over 4. A raised to power minus 3 over 4. We can first of all convert it to 1 over a raised to power 3 over 4. Then this is the case of n raised to power positive fraction. But we are going to now convert it to 1 over, we have a root. So it's a quadratic root. We have a, we have a 3. So these are the rules of indices. These are the rules of indices. We can also have this. We can have a coefficient 2x raised to power 6 times 3x raised to power 7. We can have it in this way. So anytime we're having a coefficient, then the coefficient will first of all multiply each other. It's not by addition this time. They will multiply each other while we pick one of the variables. We pick one of the one that is the base. One of the base, then we add the power. So this is solution. We can say we have 2 times 3, which is 6. 6 plus 7. which equals 6s raised by 13. 6s raised by 13. Okay? That's how to handle that. That's how to handle that. That's how to handle that. Now, in indices, we must know how to handle the perfect square, perfect cube, and so on. For example, if we have a 4, 4 can be expressed as perfect square in this way, which we have a 2 raised by 2. 2 raised by 2. 9 can be expressed as a perfect square, which is 3 raised by 2. And 27 can be expressed as perfect cube, which is 3 raised by 3. This 3 raised by 3 does not mean we are saying 3 times 3. No. This 2 raised by 2 is 2 times 2. According to indices, that means this one is having 1. This one is having 1. So that means we now have 1 plus 1, which equals to 2 raised by 2. So that's where we got this. Look at this. This will give us 3 times 3. 3 times 3 will give us 9. And we're going to have 3 raised by 2. So this one is 3 times 3 times 3. 3 times 3 will give us 9. 9 times 3 will give us 27. So we can also have something like this. We can also have something like this, 16. And we take it to what? We take it to 2 raised by 4. Yes. Which is 2 times 2 times 2 times 2. So this thing can be applied when we have indices question. When I have question on indices. Look at this question now. Look at this question now. Look at this question. 4 raised to the power 5 times 16 raised to the power 6 times 2 raised to the power 7. So don't forget that when there is power in any expression, we don't just multiply direct. We'll handle the power first before we check if it's easily multiplied or expressed as a whole number. Okay? So look at, we just say, okay, let's check the simplest one. Let's assume it's 4 and 16. Will I just break this 16 to give us 4 raised by 2? Because 4 times 4 is going to give us 16. Okay? But we have the smallest value here, which is 2. So we are going to break everything to become 2, 2, 2. So we have a 2 raised by 2. Okay? Then we have a 5. The 2 we have to meet 5. Then times 2 raised by 4, we have a 6 times 2 raised by 7. So all of them is now 2, 2. The base is now 2, 2, 2, all true. So we now have 2 raised to the power 10. Because 2 times 5 is 10. Times 2 raised to the power 24. Because 2 times 4 times 6 is 24. Times 2 raised to the power 7. Okay? So we'll now pick one of the base. We pick one of the base, which is 2. So 10 plus 24 plus 7, which is equals to 10 plus 24 is going to give us 34 plus 7, which will give us 41. Okay, 41. So we have a 2 raised by 41. So this 2 raised by 41, you don't need to come and multiply it to be 82. No. That means we have 2 in 41 places. 2 in 41 places. Okay? So now let me check another one according to perfect square. According to perfect square. You can have a 9 times 27 times 3 raised to the power 4. 3 raised to the power 4. So if you want to solve it, we just say we are having 3 raised to the power 2 times 3 raised to the power 3 times 3 raised to the power 4. So they now have the same base. So that is 3, 2 plus 3 plus 4, which is equal to 3 raised to the power 10. 3 raised to the power 9, sorry. 3 raised to the power 9. That is the answer to the question. That is the answer to the question. Okay? So this is law of indices. So let me give you another law. The law of the law of distribution of power. The law of distribution of power. So if you have a B raised to power 2, so we distribute the power to give us A square B square. That's the law of distribution of power. Whereas we have if we have AX BX, we can convert it to A B X. So we are able to distribute the power here, and here we separate the power. We separate the power. Okay? So that is the law of indices. But I'm going to be giving you, we are going to be solving some questions now, so that you'll be able to handle questions on your own. Let's assume we have and don't also forget that if we have different bases, we can multiply the base together, but the power will not be added. That's just different. If we have different bases, we can multiply the bases together, and what? We don't need to add the power. For example, if I have A raised to power 6 times B raised to power 7 times C raised to power 8. So this kind of situation, we don't need to add the power because the bases are different. So solution, we have it to be A raised to power 6, B raised to power 7, C raised to power 8. So this shows that there's multiplication. It shows that there's multiplication in between them. So that is the answer to the question. Now, let us see if we can solve one or two questions. See if we can solve one or two questions. So I have a simplify S raised to power 4 times 1 over 4x raised to power 6 times s raised to power 7 times y raised to power 8 times 1 over y times z raised to power 9 times z raised to power 6 times z raised to power minus 1 times 4. So solution. So we pick all the ones that have the same base together and add the power or subtract it. So that the first and foremost, we have to convert this. First of all, we'll convert this to a straight expression. So that means we have x raised to power 6, x raised to power 6 times 4 raised to power minus 1, x raised to power minus 6. Okay? So times x raised to power 7 times y raised to power 8 times y raised to power minus 1 times z raised to power 9 times z raised to power 6 times z raised to power minus 1 and times 4. So we quickly handle them one after the other. So these are x. So all the x, we bring them together. So that means I have an x raised to power 6 minus 6 plus 7. Okay, don't forget that this 4 cannot be joined with this x. So because it's a whole number. So it's even number, not even a whole number. So times 4 raised to power minus 1 plus 1. So we are going to handle the 4. Okay, times y raised to power 8 minus 8. When you are adding, okay, let me say plus minus 1. Yes, let's put it that way. Because though you are supposed to add it, but there's a minus coming here. Then times z raised to power 9 plus 6 minus 1. So the same thing applies. Minus will multiply times plus will give us minus. So this minus 6 minus 6 is 0 plus 7 we have x raised by 7 times minus 1 plus 1, we have a 0, 4 raised by 0. Then we have times y raised power minus times plus become minus. So 8 minus 1, we have a 7. So we have a times z raised power 14. Because 6 minus 1 will give us 5. So this will give us x raised by 7. X raised by 0 is 1. So 4 is 1. So we have a y raised by 7. Z raised by 14. Z raised by 14. So we can easily have it in this way. X, y, x, y, z, 2, 7. Okay. So that we want to use the 7 to multiply open the bracket to get more. So that is how to handle this kind of question. That's how to handle this kind of question. So let's take other questions. Let's take other questions on indices. Let's take other questions on indices. Simplify 2n over 2 square root of 4n over 3 cubic root of 6n over 4n over 3 raised by 1 over 4. So let us see how we can handle this. Let's see how we can handle this. What is first of all the solution? Is to see how we can convert this. Remove all the roots and turn it to power. So I told you that when you didn't see anything here, 2 is there. So when it's going to become power, it becomes 1 over 2. Same thing I'm doing here. So I have 2 raised by n over 2. Then times 4 raised by n over 3 times 1 over 2. This 1 over 2 here will be brought in. Then times 6 raised by n times 1 over 2 over 4 raised power. I told you we're going to multiply. So this and the y will fraction 1 times n will give us 9. 3 times 4 will give us 12. Okay. So we check. Are they having the same base? Are they having the same base? Okay, let's see. So we can easily convert this so that they can have the same root. Okay, let me finish the top. We have a 2 raised by n over 2 times 2 raised to power 11 the top. 4 into, to multiply this, that's n over 6 times 6 raised by n over 2 over 4 raised by n over 12. Okay? So I'll convert it so that they can have the same base. So that they can have the same base. That means I have 2 raised by n over 2. 2 raised by n over 2 times 2 raised by 2 into n over 6 times 3 times 3 raised by n over 2 times 2 raised by n over 2. Okay? Okay? Is it possible? Is it possible? This one is not possible. So we have a 6 raised to n over 2 over 2 raised to power 2n over 12. So we multiply, okay? Multiply, we have a 2 raised to n over 2 times 2 raised to power 2n over 6 times 6 raised to n over 2 over 2 raised to power 2n over 12. Okay? So I have a 2 raised to power n over 2 times 2 here 1, 2 here 3. We have a 2 raised to power n over 3, then times 6 raised to power n over 2. Okay? So we now have over 2 raised to power 2 here 1, 2 here 6, n over 6. I progress by finishing it. Okay? So we have the same base for this. So that means we are going to multiply this 2 raised to power n over 2 plus n over 3. This one is a division, then we have to subtract minus n over 6. Then times 6 raised to power n over 2. So this gives us, we are going to look for the SCM at the top here. So 2 raised to power, SCM is 6. SCM is 6, we have a 3n plus 2n minus n, then times 6 raised to power n over 2. So we have a 5n minus, that means 4. So 2 raised to power 4n over 6 times 6 raised to power n over 2. You can see that it was we have a quotient before as a division, but now no more division. So we have a 2 in 4 here, we have 2 here, we have 3. That means we have a 2 raised to power 2n over 3 times 6 raised to power n over 2. So this is the answer to the question. This is the answer to the question. So we can also, so this is indices. This is indices. Let me, please try to like the video. Just click on the like, then you subscribe to the channel so that we can be serving better. You can easily be seeing the video anytime any video is dropped. Apart from that, try to share it. Share the link to others. Okay? Thank you.